So let us look at another tutorial question here under projectile motion. The question says a projectile is launched with an initial speed u at an angle theta above the ground. So let's do a simple sketch here so that we can actually know what we are trying to talk about. Okay, so it's like this type of arrangement. So this is our velocity. We have x here, sorry, y there and x there. Of course, at this particular point we have our maximum height, and the distance from there to there is the range. Okay, now they're saying show that the time of flight is given by tu sine theta over g. How do we derive this? All right, so let's proceed. Let's start. So we are going to use equations of motion. All right, and I know by now you might have known this equation of motion. Okay, this equation of motion, you are aware of it, right? So we use this one, we are trying to look for the time of flight. So from here we can derive our time of flight altogether. Why am I using y? Because the motion is actually in the horizontal, sorry, in the vertical motion. It's a vertical motion. Okay, so we consider the vertical motion if you want to find the time of flight. It's simple as that. Now in the vertical motion, we need to understand to say velocity in the y is given by initial velocity sine theta. Okay, and the velocity in the x is given by u cos theta. Take note of these two formulae. So we have y equal to u here is sine theta. Sorry, it is u sine theta. It is in the y, so I'm need to put y there. So this will be u sine theta times t. Now because the motion is going up, so this will be minus 1 over 2 then g t squared. Now I want you to take you back a bit. So once this lands here, okay, once the object lands here, meaning it would have moved the entire distance, meaning the distance there is what? 0, because once it lands here the distance goes to 0. So we assume we take that notion in mind, meaning we have 0 there. Okay, which will give us if I factorize here, I've got t, right? Then u sine theta minus 1 over 2, I get gt, like that, of which I can equate this. All right, I can equate this, which is going to give me so here I have of course I can't have t as 0. Of course I know that from here t is 0, or u sine theta minus half gt is equal to 0. So I can't have t as 0. So I'm going to take the non-zero solution, which is this one here. So from there, I just have to make t the subject of the formula. So if I make t the subject of the formula, I'm getting half gt equal to u sine theta. So my t is, okay, so just make t the subject of the formula here. And because of the 2, so the 2 multiply this side to give us 2u sine theta over, then here what we have to be g, which is the formula for the time of flight given by capital T, 2u sine theta over g. You've derived. It's simple as that. Now myself, I like to know how to come up with things. I'm not good at mastering equations, but if I know how to come up with them, that is what you should be going for as well. All right, I would advise you know how to derive these equations from scratch. Okay, then B says derive an expression for the horizontal range, this range. Okay, now range is just distance. All right, the same way you know that distance is given by speed times time. Even here, range is just velocity in the x times time. Because the range is in the x-axis, it will be velocity in the x, and the velocity in the x is given by this. So our range will be equal to u cos theta multiplied by what? T. Now, why am I using capital T? Remember to say from here to here, the time it's going to take is called the time of flight, which is capital T. So from there, we just have to substitute the value of t here. All right, so this is u cos theta. The value of t is what? It's here. It's 2u sine theta over g. do the substitution there. Perfect substitution. Okay, we now expand. Okay, we now expand. There's u here and there's u there, which are going to give you 2u squared. Then there's cos and sine multiplying, so get cos theta sine theta, and this will be divided by what? By g. Now let me just arrange this properly. This is u squared 2, and I want to arrange it properly. Sine theta cos theta over g. If you don't know what you are doing, you can add here, but if you remember the double angle identity for sine 2 theta, sine 2 theta is 2 sine theta cos theta. So knowing this identity in your mind, you can just substitute where the sine 2 theta cos theta with sine 2 theta. So our range goes to u squared. All this part here is just sine 2 theta over g, which is a range. Done. But the next part which we are going to look at is C. Show that the maximum range occurs at theta equal to 45 degrees. So how do I show that the maximum range maximum occurs at 45 degrees? Well, here's what you need to do. Okay. Replace. So we have sine 2 theta, which will be sine 2 times 45 degrees, which will be sine 90 degrees, and sine 90 is just 1. Sine 90 is what? Is 1. Now, if sine 90 is 1, okay, is 1, right? And 1 occurs at the angle 90 degrees, meaning 2 theta is just equal to 90 degrees, okay? And if you divide by 2, you're still getting back your theta as 45 degrees. The question is, have we answered the question? Yes, it's simple. Look, sine can go as far as positive 1 and negative 1. That's the maximum value we can get for sine, right? So the angle that you got here, sine 2 theta, just get the 2 theta and equate it to 90, okay? Equate it to what? To 90. So the same sine 2 theta, or just get the 2 theta, equate it to 90, and you'll be getting your 45, because you've already determined to say that's the maximum value you can get, even if you put sine 90 there. All right, so I think I've answered most of the questions here. Know how to derive them. It's very important. This is my WhatsApp number. I do online tutorials, very affordable, for Phi 1000, which is introductory of physics, and Che 1000, which is introductory chemistry, as well as mathematics 1100, or introductory, all right, courses like math, whatever math course that you have, math 110, math what, I do tutor them. You can also inbox me so that we can talk, and so that you know the pricing.